we have a lot of trig identities, and one of the trig identities is sine twice x. So this is twice sine x cosine x. Without this identity, we will not be able to solve this equation. So this piece will be replaced by 2 sine x cosine x. So 2 sine x cosine x equals sine x. Anyone would like to tell us how to proceed? Anyone would like to help here? How do I continue? Any suggestions from anyone?
Can we divide sine x on both sides?
Say that again.
I was saying, can we divide sine x on both sides?
Very good point. Very good point. Never divide both sides of an equation by x or an expression containing x. Oops. Containing x. Never. Reason is you will miss solutions. Okay? So other suggestions. It's okay. Tell me what's on your mind so we can address and correct. Thank you for saying that. So if I cannot do that, then what is my next step?
Can we subtract sine, move it over to the left?
Absolutely. So 2 sine x cosine x minus sine x equals 0. Perfect. Excellent. What is our next step now? Any suggestions, anyone? Who was that who told me that? Was it Rachel?
Yeah.
Thank you.
Next, can we factor out sine?
Of course. Factor out the common factor. Remember, factor, simplify. I cannot stress enough. So sine x, what is left in parentheses?
2 cosine x minus 1.
Yes. Good. So then there are two possibilities. Either, these are my props, either sine x to be 0, and what is the other option?
Cosine of x equals -1.
We move negative
I'm
1.
sorry, -1/2.
We move -1, and we divide by. Very good. Awesome.
Sorry.
No worries. Okay. Now you understand why we can never divide both sides by sine x or x. Good. So now let's talk about the unit circle so we can solve those. Any questions so far, please? You're responsible to tell me if you're falling behind or if you need anything, right? Because I will not know. So let's take a look at the unit circle. So this is the x-axis, and this is the y-axis, and this is a center angle. I'm going to call it alpha. I'm going to call this point P of coordinates x, of course, comma y. And if it's a unit circle, the radius is 1. I'm going to remove that piece, that little angle or triangle from there. So this is 1, this is x, and this is y. And this is angle alpha. So what does sine alpha equal to and cosine alpha equal to?
Sine would be y over 1.
Good.
And x over 1.
Yes, awesome. So basically this is cosine alpha. And this is sine alpha. So please remember, sine is measured on the y-axis, and cosine is measured on the x-axis. So cosine is positive and negative. Sine is positive and negative. Okay. So now, knowing that, remember, any point on the unit circle has cosine first of the angle and sine second of the angle. So if I look at this point and I know it's 1, 0, I know that this is cosine and this is sine. Cosine measured on the x-axis, sine on the y-axis. Right here for pi over 2, I know that this is 0, 1, which means cosine is 0, sine is 1. At this other point, I have negative 1, 0, clearly cosine and sine. And for 3 pi over 2, I have 0, negative 1, cosine, sine. So you never have to memorize these. Once you understand that this is cosine alpha, sine alpha, then you know these points. Okay. So now I always show this tiny little table with pi over 6, pi over 4, and pi over 3. With sine and cosine. You don't have to memorize anything else. Just this tiny table. This is the smallest angle, or 30 degrees, 45 degrees, and 60 degrees. All you have to remember is that this is 1/2. It jumps here. This is the square root of 3 over 2, and it jumps here. And these are the only same values. And now finally we can solve those two equations. One of them was sine x equals 0. So sine x equals 0. So this is sine. This is sine. Sine here is 1. Sine here is negative 1. So 0, 0, it has to be at 0, at pi, and at 2 pi. So x equals 0, pi, and 2 pi. Now the other equation is cosine equals 1/2. So for cosine x to be 1/2, I know that it's the big angle. But there are two angles. Let's take a look. Cosine 1/2 means half here, because cosine is between 0 and 1. 1/2 is just half of this. Draw a vertical line, and that's how you get your two angles. Here is one angle, and here's the other angle. What angles? This one and this one. Both of them have the same cosine, which is 1/2. So can anyone tell us those two angles with cosine 1/2? Because cosine is measured on the x-axis, is positive here and negative here. Sine, again, positive here, negative here. But we're talking about cosine 1/2. What is the angle that has cosine 1/2?
60 degrees.
Good, pi over 3. And this one, here's how we determine this. From 2 pi over 3, we go back. From 2 pi, we go back pi over 3. So this angle is 2 pi minus pi over 3. 6 minus 1. 3 times 2 is 6, minus 1 pi. So x equals 5 pi over 3. Of course, you don't have to write all this. I had to explain. So you have to write this and this and this and this and then this piece, right? So I had to explain and refresh your memory. Maybe you didn't need it. I did it anyway. And also refresh your memory on this. So I never want my students, it's up to you, but you never need to, let's say, memorize cotangent of pi over 3. Who cares? Cotangent of pi over 3 is cosine over sine. So it's this over this. That's all I need to remember. And then I can calculate, flip, and simplify. That's all you ever need to remember. But also, of course, these points. Anything else? Is there anything else, or can I start to that one? Do you need help with anything else? Do I still need to keep this here?
Did you do 21?
Say it again, Joe.
21?
You said 21?
Yes.
Yes. Let's take a look at 21. So arc sine of sine 3 pi over 2. Okay, I see it. Good. So in general, we say that arc sine of sine alpha is alpha. Also sine of arc sine alpha is alpha. How come? Well, because I'm applying the inverse function to the function. So this will cancel this, and the answer is alpha. Same thing here. I'm applying the inverse function to this function, so this is alpha. And it's all good and nice, but the answer is not so fast. So what do I mean by that? What is my point here? Okay. Let's look at sine function. As you know, the graph is this, and it goes on forever. It's a periodic function, yada yada, it goes on forever. How can a function that is not one-to-one by the horizontal line test, this is not one-to-one. How can a function that is not one-to-one have an inverse? That's not possible. Not one-to-one, it cannot have F inverse. So then what happens? The mathematician said, wait a minute. We can make it be one-to-one by truncating the domain. In other words, we're going to, just for the purpose of the F inverse, we're going to say that this is sine x. It's one-to-one. Now, by the horizontal line test, it's an odd function, symmetric with respect to the origin, and it covers all possible values from -1 to +1. So for the purpose of determining or establishing or developing the inverse function, we will say that the domain of this function is only, which is not true. The domain is everything. But we are going to say, in order to determine this or have it available to us, we're going to say that the domain of function sine is only this. And yes, the range is -1 to 1. So now arc sine, the inverse function, will be defined on -1 to 1, and the range better be an angle between -π/2 and π/2. I meant to write an arrow, a -π/2 to π/2. So coming back to our example, if I blindly say 3π/2, because the function, this eliminates the inverse, it's the inverse of this, that would be wrong. 3π/2 is not here. Where is this? Here. Between -π/2 and π/2. But you can say 3π/2 is right here. Yeah, but I cannot write 3π/2. So all this point is telling us that in this case, I cannot use the concept of a function applied to the inverse or vice versa, the inverse applied to a function clears their effect, they cancel one another, and the answer is 3π/2. Can I still get the answer? Of course, but I cannot write 3π/2. I have to find the sine 3π/2, which I already know, it's -1. And then I have to apply arc sine to -1, which I know what it is, it's -π/2. So arc sine of sine 3π/2 is arc sine of -1, which equals -π/2. So be very careful every time you think in terms of inverse trig functions. You have to think about the domain. You cannot blindly write, oh, this is the inverse function of that. Goodbye. I can write 3π/2 because you cannot. And I'm going to share my screen because I am just curious for a second. I've never tried to see what the calculator is saying. So sine inverse of sine 3π/2. I am just super interested now. Since you asked that question, I never looked at it. The answer has to be -π/2. So sine inverse of sine 3π/2. This is -1, and the answer has to be -π/2. Sorry, guys, you're in the way. Aha. And here it is, -π/2. So in this case, we cannot blindly consider sine inverse applied to sine. Boom, just write 3π/2. Because of the way the function works, and because of the truncated domain of the function. Very good question. Anything else for me here? Anything else? Yes?
I don't really get this whole arc stuff that you're doing, or how's this entire question has me lost.
So which part is not clear?
The whole like arc thing, it's just kind
It's the inverse function.
The entire thing is just kind of overwhelming.
So this is the inverse function. So when we have a function that is 1 to 1, normally we write it like this. Oops, 1 to 1. The function has an inverse. And the function composition in either direction has to equal x. And the same thing happens with the trig functions. So the arc sine x is the same with sine inverse x. I don't like to write it like this, although the calculator has this, not the arc sine, because some students think that this is 1 over sine, which is not. This only says the inverse sine, the inverse function of sine. In other words, so what is the inverse, right? So sine of pi over 6 is 1/2. We know that. So now, so let me give a different example. So sine x is 1/2. How do I determine what is the angle whose sine is 1/2? I apply to both sides the inverse function. Either I write it like this, or I write it as arc sine. Same thing. Sine inverse or arc sine is the same thing. So sine inverse of sine will be x, and sine inverse of 1/2 will be pi over 6. So when we apply sine to an angle, we get a number. When we apply sine inverse to a number, we get the angle back. Is that better?
Yeah, I think I'm starting to get it.
Right. So these are just two functions that are inverses of each other. Remember, I think you told me, I think, or somebody else said, when we had e to the x plus 2 equals 3, why did we apply natural log to both sides? For the same reason I apply here sine inverse to both sides. Because natural log will undo e to the x. Why? Because natural log and e to the x are inverses of each other. Why do I, when I solve the equation this, why do I square both sides? I don't want to square. I want to take to the third power. But that will not help. Because power 3 and power 1/2 for the square root are not inverses of each other. Only power 2 will do the trick. The same thing here. We have a function that is the inverse of sine. It reverses the effect of sine on pi over 6. Natural log reverses the effect of e to the x to anything else. Power 2 reverses the square root. So that's why we get x plus 2 equals 9. That's why here we get x plus 2 equals natural log 3. Same thing, sine has an inverse function. Like e to the x has an inverse function. Like the square root has an inverse function. Is that better?
Yeah.
So I highly recommend you can review this. It's in, let me share my screen. So it's also in the review module. So for more practice. Not in the getting started, but in module 1. I have to wait for a second till this uploads correctly.